Hi friends, this is Lakshmi from Sri Venkateshwara College of Engineering. Today I am going to discuss about topic corrosion. In corrosion, I am going to discuss about introduction, basic types, types of corrosion and corrosion control methods. Let's get started. Introduction. Corrosion. Corrosion can be defined as a destructive chemical and electrochemical reaction of a metal with its environment such as oxygen, moisture, carbon dioxide, etc., which disfigures the metallic products leading to the reduction in their thickness and also some properties such as malleability, ductility, electrical conductivity. Then examples are rusting of iron due to the formation of hydrated ferric oxide. Second one, tarnishing of silver wires in H2S laden air due to the formation of silver sulfide. Here are some examples of corrosion. You can take a look on it. These metals got corroded by continuous contacting with the moisture, air, water, and other gases. You can look the rust is in brown color means it is an iron metal. Okay, let's discuss about basic types of corrosion. There are two types: dry and wet corrosion. Dry corrosion, which is also called as chemical corrosion. Wet corrosion means it is also called as electrochemical corrosion. Dry corrosion. Here it involves the direct attack of chemicals on the metal surface where it is contacting directly. And then corrosion occurs in the absence of moisture. Mm. And the dry corrosion process is slow when compared to wet corrosion. The process of corrosion is uniform. Okay. An example goes like formation of AgCl on the silver metal. Wet corrosion. It involves the formation of electrochemical cells. It is formed by the formation of electrochemical cells. Here, it occurs in the presence of conducting medium and it is a rapid process. It depends on the size of the anode part of the metal. Means here the corrosion process will depend on the size of the anodic part. Examples such as rusting of iron. Types of corrosions. We are having two types: differential metal corrosion and differential aeration corrosion. First, let's discuss about differential metal corrosion, which means which occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode and undergoes oxidation and gets corroded. And then the other metal with a higher electrode potential acts as cathode, which undergoes reduction and protected from the corrosion. This type of corrosion is also known as galvanic corrosion or differential metal corrosion. Here in this process at the anode, the metal undergoes such reaction and at cathode, reduction reaction takes place depending upon the nature of the environment. Here the water is reacting with oxygen to form OH minus. Examples such as tin coating copper vessels, steel pipe connected to the copper plumbing. And third one, bolt and nut made of different metals to avoid corrosion. Okay. When iron is in contact with copper, and iron becomes anodic and undergoes corrosion, whereas copper becomes cathodic and remains unaffected. Now let's discuss about differential aeration corrosion, which means when a metal is exposed to a different concentration of air or oxygen, part of the metal is exposed to the lower concentration of oxygen and which becomes anodic and undergoes corrosion. Whereas the other part of the metal exposed to the higher concentration of the oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. Example, we can take iron rod partially immersed in the NaCl solution. Okay. Then part of the metal immersed in the solution is exposed to the lower concentration of the oxygen and which becomes anodic and undergoes corrosion. Whereas the part of the metal which is outside the solution or outside solution is exposed to more oxygen and becomes cathodic, which remains unaffected. In the figure, you can see that the rod is immersed in the solution, initial solution, where here less oxygen is there, right? It is anodic part, which is uh, got corroded more, and the upper part is less corroded because it is not with contact with more moisture, and the reactions takes place such as at anode iron gains 2 electrons, at cathode it remains the same. Waterline corrosion, it is observed in steel or iron water tanks partially which is filled with the water. When a steel tank is partially filled with the water for a long time, the inner portion of the tank below the water line is exposed to the dissolved oxygen where it does not got corrode, and the portion above the water line is exposed to more oxygen. Thus, the portion below the water line acts as anode and undergoes corrosion. The upper portion acts as a cathode and it is unaffected. Okay. A distinct brown line is formed just below the water line due to the deposition of the rust. Thus, where the rust is formed on the upper line of the water, where the tank and the water border is there. The reactions are like this. At anode, the metal gains the electrons. At cathode, the water and oxygen, moisture, etc. forms the OH molecules. Finally, the ions combine to form corrosion product. This is called as waterline corrosion. Pitting corrosion. This type of corrosion is observed when the dust particles or oil drops deposited over the metal surface. This can be caused due to metal surface is not homogeneous, external environment is not homogeneous, or crystallography directions are not equal to the reactivity, or environments are not uniform with respect to concentration. Pitting corrosion results when the portion of the metal covered by the dust, which is less aerated, becomes anodic and undergoes corrosion and form a pit. The remaining area of the metal, which is exposed to the higher concentration of the oxygen, becomes a cathodic and remains unaffected. Example, once a small pit is formed, the rate of corrosion increases because the formation of the small anodic area, which is called as pit, to corroded faster because accepting electrons from the cathodic area increases. The reactions are like this. At anode, you can see in the figure, dust particle and the pit. Where the dust particles are there, the metal got corroded and it forms a pit. It is called as pitting corrosion. Let's discuss about corrosion control methods, where corrosion can be controlled by preventing the formation of galvanic cells on the surface of the metals. The types are the methods are design and selection of materials. Second one, protective coatings. In that, inorganic coatings and metal coatings. In metal coatings, anodic coating and cathodic coating. Third one, cathodic protection, in which sacrificial anode method and impressed current or voltage method. Protective coating. In this method, the metal surface is isolated from the corrosive environment by protective coating. Okay. Metal coating, which means the process of coating base metal with a layer of protective metals. And anodic coating means in this the coating the metal is anodic to the base metal. Examples such as galvanization. Galvanization means the process of coating steel or iron with a layer of zinc to protect against corrosion. The process of galvanization takes place such as the metal surface is washed with organic solvent such as CaCl4 or toluene to remove organic matters. The metal surface is treated with a dilute H2SO4 to remove rust and other deposit at the first step. Then it is well washed with water and it is dried by passing hot air. Later on, the metal is treated with the zinc chloride and NH4Cl solution, which prevents the oxidation of the coated metal. The metal is dipped in molten zinc at 450 degrees Celsius. Then after all this process, the metal can be avoided from the corrosion. The galvanization process looks similar to this, where the iron sheet is dipped in organic solvent and then H2SO4 solution and dried with the uh, hot air or washed with the water, and then the solution zinc chloride NH4Cl, it is dipped in that solution and later it forms the molten zincs, and later on we'll get the galvanized sheet. Cathodic protection, which means it is a technique of offering protection to the specimen against the corrosion by providing electrons for an external source, in which let's discuss about the sacrificial anode method. It is the method where it involves the use of metal which is anodic to the specimen. In this method, the metallic structure to be protected is connected to more anodic metal by using a metallic wire. These are commonly used sacrificial anodes such as magnesium, aluminum, zinc, and their alloys. Example, protection of ship's hull by fixing zinc plates. Second one, protection of underground pipeline with a magnesium anode. Impressive current method. In this method, the electrons are supplied from a source of a direct current or battery. Advantages are requires low installation and like cost and minimum maintenance cost after installation. It is used for protecting water storage tanks and oil pipelines.